Welcome back, Math 7. Today's lesson is chapter 12.4. The title is The Effects of Outliers. Sorry about that. The title is The Effect of Outliers, and the page is textbook page 440. So, first thing first. Again, let's talk about outliers. If you think about some of the data, I am randomly generating some data. Imagine you have this 1, 2, 3, 4, 5, 6, 7, 8 datas in here. And it's relatively random. Let's make it into ascending order. 3 is the smallest, then followed by 7, 8, 8, 8, 9, 9, then 14. So you have basically 8 set of data, 8 values, in this set of data, and you can determine the smallest value or largest value that may play a huge role that disrupt the central tendency, and that is outlier. For example, if I look at this number 3, compared to any type of value in here, 7, 8, 9, it's quite small. Like, for a value to represent the central tendency. On the other hand, 14 is too large of a value that it may interrupt the central tendency when we calculate the average. So these two values basically can be considered as an example of outliers. And outliers basically affect the measure of central tendency, because whatever the large, or let's start with the small one, if the value is too small, if we include this small value, then we bring down the average because the value is too small. On the other hand, if the value is too large, then what's going to happen is basically average value will increase. So long story short, you need to understand that we need to judge whether we exclude the value or include the value. And when I say value, it's outlier. And we need to determine whether that makes sense or not. So without further ado, let's go with some example. The example that I'm going to go through is on page 442. This is a classic example. Before getting into the classic example, I need to copy a table. And the table basically shows the number of baskets. So let's go with the example. Shannon practiced shooting baskets every day last week to prepare for a basketball tournament. She recorded the number of baskets she made each day out of 25 shots. So, Shannon have day and number of baskets. So basically day 1, Sunday, all the way to we have 7 days, and the number of baskets out of 25, 14, 17, 16, 25, 22, 18. Although the textbook shows Sunday, Monday, I just put 1, 2, 3, 4, 5, something like that. And we are basically going to determine the outlier and effect from it. But before we do, first step we need to understand is find out the range. It is important to find out how far things are apart. So for example, the highest value and lowest value, highest value is 22, lowest value is 5. Range is basically subtraction of those two. So 22 minus 5, which give you 17. Now, know the fact that if you think about the range, and this basically includes your, how can I say, your justification of whether you want to include the value or not. Out of 25 trial, 17 seems like a huge gap. The reason that I put out of 25 is, well, maximum that you can score out of 25 shoot is 25. So 17 itself is really big gap in this experiment or in this observation with the data. So here's what you need to do. We may need to exclude some of the outlier. Before we getting into, let's go with B. B. The question is asking you to find out the value of median and find out the value of mean for everything. So let's give it a shot. First thing first, we need to make the whole arrangement ascending order. So 5 followed by 14, 16, 17, 18, 20, 22. We have 1, 2, 3, 4, 5, 6, 7 data. So the one that is exactly located in the middle is 17 because it's an odd number. So median is 17. Mean value is adding every single thing. 5 plus 14 plus 16 plus 17 plus 18 plus 20, 22 divided by 7 is my data number. So once you punch the number in calculator, it's 112 divided by 7. And you can use your calculator because most of the time it's giving you some kind of nasty number. Oh, but in this case, it's actually 16. Rarely you get a clean number, but this example gives you a clean number. So average value, if you use median, that's 17. If you use mean, then it's 16. But at this point, it is debatable. Why? Because of these two values. Like I said, number basket for 5 and 22. This guy raised the average. Oops, sorry. 5 reduced the average. 22 increased the average. So to compensate that situation, which is basically part C now. It is important to sometimes exclude the outlier. Let's exclude 5 and 22 out of the list. Then let's calculate median and mean value from it. First of all, 5 is gone, so you have 14, 16, 17, 18, 20. In this case, median value is still in the middle, odd number, so 17 was my median value. Median value didn't change. On the other hand, mean value, there is some change. 14, 16, 17, 18, 20 divided by 5 is what you need to do. And once you do the calculation, everything will be a little bit better. And Let's just use calculator for this one. So I'm getting a little lazy. Where's calculator? 14, 16, 17, 18, 20. Provide you 14, 16, 17, 18, 85 divided by 5. Generally, it can give you decimal value. Not for this situation. It's a divisible by 5, so 17. Mean value changed. As you may notice, it may not affect the whole situation, but by excluding it, central tendency calculation may become more accurate because we are excluding any of an outlier that may drive the average up or down. So, excluding outliers, how can I say? Helped us calculate the central tendency better. That's what I want to point that out. Because 5 shoot or 22 shoot doesn't seem representing the normal average situation. So have that in your mind. You need to use your judgment, and if the range is too far, it is a good idea to exclude. That is today's lesson. Your homework is your textbook page number 3, 4, 5, followed by 7. Oops, I forgot to give you the page. Silly me. That's a 444, 445. That's your to-do list.